side. So this is the only equation that we will be using for calculating percent error in this class, okay? You will also sometimes see absolute value symbols here. I don't want that. And the reason I don't want that is because I want to know whether you are above or below the true value, because that will give me a positive or a negative percent error. And that's really valuable to know. Okay, so let me make a couple of units, a couple of notes here. The unit will be a percent. Also, if you have a positive percent error, that means you're over the accepted value. And if you have a negative percent error, that means you are under. And then we're going to start talking about significant figures here in a little bit. So while we're on this equation, I want to make a note that this 100% is considered an exact number. That means it will never affect the significant figures in a calculation. And I'll be talking about that as you move along. When you use percent error, your sig figs will likely change from the subtraction step. Okay? All right, so let's take a look at the quick check. Let's bring this down here. And it says a student weighed a penny, found out that its mass is 2.57 grams. Data from the U.S. Mint indicates that a penny from that year should be 2.46 grams. Okay, so this would be the measured value, whereas this would be the accepted value. Okay, when they ask us for the absolute uncertainty of the penny's mass, let's subtract to figure out what that difference is. So 2.57 minus 2.46 is going to be 0.11 grams. Okay, so since the measured value is above the accepted value, we have a difference of positive 0.11 grams because we are over the accepted value. Okay, and then when they ask us to calculate the percent error, the percent error here is going to be, I'm going to put this down here, the measure value, 2.57, minus the accepted, 2.46, divided by 2.46 times 100. Okay, now I'm going to be teaching you on the next page how to, and then the page after that, how to deal with significant figures and calculations. So for now, I'm just going to show you that when you take this subtraction step, when we learn the rules for determining significant figures, anytime you're adding or subtracting, you always want to line up the decimals and draw a line after the term that has the fewest decimal places. Both of these measurements go 2 places past the decimal, so that means whatever remains to the left of the line, that would be our significant digits. So since I technically have 2 significant digits, I'll be abbreviating sig figs as SF generally. I have 2 significant figures here. That means that my final answer should also have 2 significant figures because I'm multiplying and dividing. This doesn't mean much to you yet, but I will go over that in a second. So I'm going to divide by 2.46 times 100. I'm going to get 4.47. So 4.5% would technically be the proper answer to 2 significant figures. Okay? Let's take a look at the next page. The rest of this section is all about significant figures. Okay, so if you get lost, let me know. I'll slow down. I'll repeat myself, okay? Okay. Let's talk about significant figures. The number of significant figures in a measurement includes all of the certain figures, like when we determine the division size on a cylinder, plus an uncertain or estimated digit, okay? Now, if you've made a measurement and we're going to determine how many significant figures are in that measurement, for instance, all non-zero digits are significant. So that means the numbers 1 through 9. would be significant. Let me give you an example. If you have 56.5 grams, those are all digits 1 through 9. Therefore, this would be considered 3 significant figures. Okay. Rule number 2. All zeros between non-zero digits are significant. So we tend to call these sandwiched, captive, or trapped zeros. So if you have something like 2002 liters, okay, these are trapped or sandwiched zeros. They count because they are between the digits 1 through 9. So that means here I technically have 4 significant figures. Now, it doesn't matter whether you have 1, 2, 5, or 10 zeros trapped between the digits 1 through 9. They would still be significant. Third rule, leading zeros. That means zeros in the front of a measurement are never going to be significant. It doesn't matter if those zeros are in front of a decimal or just behind it. So 0.9 grams or 0.09 grams, for instance, these would be leading zeros. These do not count. So technically, I only have 1 significant figure in both of these measurements. Okay? Last rule, trailing zeros, which would be zeros at the end of a measurement, they only count if there's a decimal written somewhere in the measurement. So if I give you something like 560 grams versus 560.20 grams, this doesn't have a decimal, so that means the trailing zero doesn't count, so I only have 2 significant figures in that measurement. Over here, this trailing zero counts because there's a decimal, so that means here I've got 5 significant figures, and that trapped zero counts because it's between the digits 1 through 9. You follow me on this? Okay. Okay. So what we're going to do is we're going to do some practice. On the next page, there are some practice problems. So I want you to do number 1 and 2 with the person sitting next to you, and let's see what you guys come up with. Okay, for number 1, do we all agree on that? Okay, and just I made the note that if you have something in standard scientific notation, don't expand it. Look at the decimal portion only and determine how many sig figs are in the decimal portion. You're done. Okay, for number 2, since we have a 4 here, if this was a 5 or greater, then I would round this up. So this would be 30.5 seconds. That's 3 sig figs. And then for B, this one's a little bit difficult because don't I need to round this 2 up to a 3? Because everything kind of like carries over. So wouldn't this just be 0.300? Okay. And then for the other ones, or actually, no, 0.290. Because this is a 5, so this rounds up, right, to a 0. That makes this round up to a 9. 0.290. That would be 3 sig figs. The trailing zero would count because there's a decimal someplace. Okay, but the leading zero doesn't count. And then over here, since this is a 5 or greater, we would round this 4 up. So this would be 4.5 meters. And then for D, the only way to put that to 2 sig figs is to write it in standard scientific notation as 1.0 times 10 to the second degree C. Okay.
So there's no other way to signify that?
No other way. I couldn't just make it 10 because 10 in terms of a quantity is nowhere near 100. Okay? Any other questions? Okay. Then let's go on to learn how to multiply and divide with sig figs. Okay? Okay. Now, anytime you multiply and divide, your answer should have as many sig figs as the number with the fewest significant digits. That is the rule. So let's turn the page. Let's take a look at the quick check. Let's go right here. Let's take a look at number 1. Which has the fewer sig figs? 0.14 or 14.00? Yeah, so here I've got 2 significant figures because over here I've got 4. So anytime you multiply or divide, go with the fewest sig figs, which would be 2. So your answer should have 2 significant figures in it. So here you're going to get 1.96. That means this should round up to 2.0, and this would be meters squared. Okay, number 2. 940. The trailing 0 doesn't count. I have 2 significant figures here. I have 3 significant figures here because the trailing 0 counts when there's a decimal somewhere. So we're going to divide. So that means we would have 2 sig figs in our answer because that's the fewest. Here we're going to get 1105. So that means this would be 1100 grams per mil. You need to include the zeros on the end because it makes the quantity relatively similar. Okay, you can't just drop them. For number 3, here I've got 2 significant figures because leading zeros don't count. Here I have 3 sig figs because the trailing 0 counts when there's a decimal somewhere. That means I'm going to have 2 sig figs as my fewest, so that would be what I represent my answer to. You're going to get 0.04909. Underline the 4 and the 9. We're not going to round up. So this is going to be 0.049 grams per second. Okay, we good with multiplying and dividing? Okay, let's go to the other rule. Let's go to adding and subtracting. Adding and subtracting has a completely separate rule. So depending upon the operation that you're doing, you would apply the rule for that particular part of a problem, especially if it's a multi-step problem. So here it says, anytime you're adding or subtracting, your answer should have as many sig figs as the least precise number in the problem. Okay, so let's turn to the next page and let's look at the practice problems then. Okay, I strongly suggest lining up decimals and drawing the line after the term with the fewest decimal places. So let's go right here. For number 1, I've got 16.407 and 5.70. Notice I lined up my decimals. I'm going to draw a line after the term that has the fewest decimal places, which is the 5.70. Then I'm going to write down what my answer is. I get 22.107. Still add it in your calculator, but write everything down. Everything to the left of the line is what you are allowed to write in your answer. But since we have a 7 here, this 0 rounds up to a 1. So that means you're going to get 22.11 milliliters as your answer. Okay? Then for the next part, we've got 0.32 plus 0.009. Draw your line after the 0.32 since that has the fewest decimal places. This is going to be 0.329. And then you're going to underline the digits to the left of the line. And then since this is a 9, this 2 rounds up to a 3. So 0.33 grams. And then for the last one, you want to be really careful. 750 plus 8.001. Okay. You have to draw your line after the measurement that is the least precise. Technically, this one would go here because that trailing 0 is not significant because there's not a decimal somewhere to make it count. Okay, so this would be 758.001. Underline the digits to the left of the line. That's what you're allowed to have in your answer in terms of it being significant. But since this is an 8, the 5 rounds to a 6. So this is going to become 760. You can't round it to 76. Quantity would be nowhere near 758. And then this would be meters. Okay, how do you feel? Yes.
Why wouldn't you do anything with the 1 on the very right? Like, would you round up at all, or just?
No. I'm only worried about rounding this up based upon what's immediately after it. That is your question?
Yeah.
Yeah.